Hi everyone. So in this lesson we're learning about angle measures and segment lengths formed by tangent lines and chords, and a new type of line that we're going to learn, a secant line. So let's take a look at our theorems and then we'll try some examples. So first we have a secant line, and a secant line is a line. So remember, a line has arrows on the ends. It keeps going forever. And it's a line that intersects a circle at 2 points. Okay, so that means it intersects. It's going to keep going through the circle. It's not a segment like a chord was in the last one. So, not the last one, the one before that. So remember, a chord is going to stop. Okay, whereas a secant line goes all the way through, and it keeps going. It has arrows on the ends. So, they make special angle relationships, and these angles are true for chords as well, the next theorem. So it says that the measure of an angle formed by two lines that are that intersect inside the circle, so you see how they meet inside the circle, is half the sum of the intercepted arcs. Or not, yeah. So the measure of angle 1 is half of x plus y. So I know it's hard to remember like where the x's and y's and all those are going to go. So I usually teach it another way. The angle is half of the big arc plus the little arc. And since we're adding them, it doesn't really matter which one you say is big or little. For the next one, it matters, but you'll see that the big one is always on the outside. So for the next one, it says that if we have the measure of the measure of an angle formed by two lines that intersect outside a circle is half the difference. So this time we're going to subtract. So as you can see, those lines are always going to meet outside, whether it's two secant lines, a secant line and a tangent line, or two tangent lines. So the measure of the angle, that angle that's out here, this angle 1, is half of the bigger arc minus the little arc. And this one on the outside is always the bigger one than the one on the inside. So angle 1 would equal half, or the angle equals half of big minus little. So here you just have to remember, if it's inside, it's going to be plus. If it's outside, it's going to be subtraction. Okay, and then the last three have to do with the segments, the lines instead of angles. So if we have two lines that intersect inside, these are two chords, so it meets inside, then we just times the pieces that are on the same line and they equal each other. Okay, so for the next two, these have ones that meet outside. These are two secant lines, and this is a secant and a tangent. Okay, but the pattern for both of them is the same. It's the outside piece times the inside plus outside equals the outside times the inside plus outside. And it's true for this one as well. So I'm going to write it a little bit differently so you don't have to memorize this if you remember like the positions. So it's outside times inside plus outside. So that was where the B was the outside part and the A was the inside part. So out times in plus out equals the same thing on the other for the other line. Out times in plus out. Okay, and that's true for both of those pictures. So for these problems that we're going to work on now, it's really, you're looking for, are we finding angles or are we finding sides? Do the lines meet on the inside or do they meet on the outside? Because that determines what formula we're going to use. Okay, so let's take a look at our first example on the inside. Okay, so are we finding angles or sides? Good, we're finding angles. And as the lines intersect inside the circle or outside? Good, they intersect outside. So the formula for intersecting outside for finding angles was that the angle equaled half of the big arc minus the little arc. And you can use the x and y if you want. I just think it's harder to remember, especially sometimes our variable like is the angle and it's an x or a y. So I like going with the big little. So our angle is going to be where the two lines intersect, so that's going to be our y, equals half. And then our two arcs are 110 and 30. So 110 is our big and 30 is our little. So y equals half of 80. So y is 40 degrees. Okay, good job. So why don't you try, well, I guess we'll do it together. I'm going to go down, well, we'll go in order. Number 2. So angles are sides. Good, we're finding sides. Nothing has a degree there, so we know what sides. And then do the lines intersect inside or outside the circle? The lines intersect right here, so it's outside the circle. And that formula was the in-out one. So the outside times the inside plus outside equals the outside times the inside plus outside. So if this is our first line, what number is on the outside of the circle? Good, that's 6. And then the inside is 8. Now on the other line, the outside number is 7, and the inside number is y. Oops, that's a 7. So from here, we just solved this equation. So distribute. On that side, you could add first. But on this side, we can't add those because a y and a 7 you can't add. They're not like terms. So that's why I always say to distribute, because then you won't mess it up. So we have 48 plus 36 equals 7y plus 49. So 48 plus 36 is 84 equals 7y plus 49. And then we can just solve it like we would a normal equation. So 35 equals 7y, so y is 5. And that's it. So really the hardest part here is remembering how to set them up. Okay, so number 3, angles are sides, and inside or outside. So angles on the inside. So that formula was angle equals half of big plus little. So our angle, this time they gave us our angle, so that's 35. And then technically we don't know which arc is the bigger one since we're looking for the arc, but it really doesn't matter since you're adding. So it doesn't matter if you put x plus 30 or 30 plus x. Okay, so for this one, since like on the first one, we could take half of the number. Here, we don't want to like distribute because, well, you could, but then you'll have to get rid of the 2 eventually. I'm going to like cancel out the fractions like the MSA way to get rid of that. So we times both sides by 2 to cancel out the fraction. So we would have 70 equals, and since the top was just 1, we don't really need the parentheses anymore. So x plus 30, and then just subtract your 30. So x is equal to 40, and that's it. Okay, so I want you to try questions 4 and 5, and then we'll do some more, we'll actually do 4, 5, and 6. So try 4, 5, and 6. When you come back, I'll show you what those ones are about, and then we'll do 7 and 8. So pause your video and do examples 4, 5, and 6. Okay, so for number 4, we were finding angles and it was intersecting on the outside. So that's big minus little. So the big one is always like the outside one, so 95 came first. I times by 2 on both sides to cancel out my fraction. And then don't forget, like I know when you subtract it's going to become a negative, but it was a minus x, so that's still negative, so you divide by the negative 1. So we get a positive 55. For number 5, it was angles on the outside again. So big minus little, we end up with 250 on that one. This one, technically, you could have just subtracted from 360 too, because this is 110 and this is 360 minus 110. So you can get 250 that way too. Okay, and then for number 6, This was another angle one, and it was on the inside, so that meant it was a sum. So this was kind of just like the first one we did, we're finding the angle, so you just have to take half of it. Okay, so let's look at question 7. So angles are sides. Good, these are going to be sides. We know it because they're on the segment and there's no degree mark. And then the two lines meet on the inside. So that was the other formula, this one, where we times the pieces on the same segment together. It equals the other segment. So if we look at this segment first, so we're going to times those two pieces together. So 7 times 3. And then on the other segment, this one is x and 9. So x times 9. So that would be 21 equals 9x. And then we just divide to get the x by itself. So x equals 21 over 9, which we can't divide out, but we can reduce it by 3. So we get 7/3. Okay, good. So our last one, sides or angles. Good. Inside or out? Good. So that was inside, outside, inside problems. So the outside times inside plus outside equals the outside times inside plus outside. So if we start with this line, outside is 8, inside is 16. So 8, 16, 8. So the other line, does any of this line go inside? Nope. So how much, what's the length of the line inside? 0. Very good. So for the inside, we're going to put 0. So the outside is x. The inside is 0 plus outside. Okay. So distribute. So x 8 times 16 is 128 plus 64 equals 0 plus x squared. So if you take a look at the formula that was on the front, that's how the formula is written, is that it ends up being that tangent part squared. But if you plug it in as 0 in the other formula, it comes out the same way. So that's why I like doing it that way better. So if we finish solving this, we add those together. So we get 192 equals x squared, and then take the square root. So x equals the square root of 192, which if you make your factor tree, ends up being 8/3. And that is it. So make sure you write down any questions you have. Werner out.